Hello and welcome, my dear students of ICSE Class 10. This is the competency series that we are doing, and today is question number 29. We have already done 28 other competency questions of the series, and if you have not watched them yet, make sure to watch them as well. The link of the playlist for the competency series is given in the description box of this video, so make sure to watch them as well after watching this video. Each and every question that we are doing in this series is extremely concept oriented and competency focused. So let's start doing this particular question. This question is from Work, Energy and Power, this particular chapter. A ball of mass 20 gram falls from a height of 45 meters. Okay, so understand what is being told. There is a ball which is falling from what height? The height has been told. It is falling from a height of 45 meters. And the mass of the ball is also given 20 gram. Alright, it rebounds from the ground to a height of 40 meter. Means when it hits the ground, after hitting the ground, it again rebounds, goes up to what height? 40 meter. That means, let us draw the diagram. So this is the ground, right? And if the ball is here, when at the highest point, that's height is given 45 meter. So this is the ball whose mass is 20 gram. It is falling from which height? 45 meter. Now when it falls down and when it hits the ground, so after hitting it rebounds. It goes up to which height? It has told it goes up to 40 meter height. So the rebound height is, after the rebound has happened, the height that the ball goes after rebounds is 40 meter. Now, we have to understand the physics over here. We have to understand the energy transfer that has taken place. That is the most important thing. What has been asked, we have to find the initial potential energy of the ball. That means we have to find the potential energy at the highest point, the initial potential energy. When the ball was at 45 meters height, the potential energy of the ball, that we have to calculate. Second, we have to calculate the speed with which the ball hits the ground. That means the speed when it just hits the ground, the speed with which it comes. Okay, so that's the second thing. The third thing is that the loss in kinetic energy on striking the ground. So after the ball has stricken the ground, it loses some part of its kinetic energy, because some part of the kinetic energy changes to sound energy, heat energy. Obviously when the ball hits the ground, you will hear a sound. Some heat due to friction is also produced. So some amount of kinetic energy got lost, but remaining part of kinetic energy caused the ball to rebounds up, and that's where we will use the physics. I will explain you this question. It's a very interesting question, and let me tell you that this question is actually a board question, previous year question. In fact, this is the ICSE question of 2026, this particular year itself. Okay, the latest board question, 2026 question it is. So you see, it's a 4-mark question from the question paper. I have directly taken the question. Let's now solve the question. So the first part, A, what do we have to find? We have to find the initial potential energy of the ball. That means when the ball is at 45 meter height, what is the potential energy of the ball? That is what we have to find. So it's very simple. Initial potential energy of the ball, and we know the formula for potential energy, right? We know it's mgh. Masses 20 grams. Of course, we have to convert it to kg. So 0.02 kgs. G is 10. It's given 10 meter per second square. Height is 45 meters. So this will give you, when you solve this will give you 9 joules. Okay. So we have got the initial potential energy of the ball. Now, try to understand, children. When the ball falls down and it has just reached the ground, at that very point, when the entire potential energy got converted to kinetic energy, it has just hit the ground, but there is no loss of kinetic energy happened. See, everything happens in a sequence. The ball is at the highest point. Imagine, this is very important. The ball is at the highest point, so it has the maximum potential energy. The maximum potential energy is present. That is what we have calculated, 9 joule. And since the ball is not falling right now at this point, when it is at the highest point, the kinetic energy at the highest point is 0. Now when the ball starts falling, this potential energy starts converting into kinetic energy. And when the ball finally reaches the ground, the entire potential energy, which was 9 joule, got converted to kinetic energy. But it has just hit the ground and the entire potential energy has converted to kinetic energy. We are talking about that instant of time when the kinetic energy has not further changed to any other forms of energy. Like, of course, in the next very instant, some part of the kinetic energy would definitely convert to heat energy, sound energy. But we are now talking about that very instant of time when the ball has just hit the ground and the kinetic energy present in the ball is 9 joule. The potential energy was also 9 joules. The entire potential energy got converted to 9 joule kinetic energy, and still the kinetic energy has not converted to any other form of energy, but it will obviously convert to any other form of energy like sound and heat just in the next microsecond. So that very instant of time when the kinetic energy is also 9 joule, what is the speed of the ball? That means that is what we have to calculate, the speed with which the ball hits the ground when the kinetic energy is 9 joule. So this is so easy. We know that the kinetic energy is 9 joule and we can calculate the speed of the ball at that point when the kinetic energy is 9 joule by the formula of kinetic energy, which is half mv square, where v is the speed of the body, the speed of the ball. So what we can do, kinetic energy of the ball when it hits the ground. So I hope you are understanding that which instant of time I'm talking about. I'm talking about that instant of time where the entire potential energy has just converted to kinetic energy. The entire 9 joules of potential energy got converted to kinetic energy. So kinetic energy of the ball is 9 joule. Kinetic energy formula is half mv square, so that is 9 joule. 9 I'm writing. Now half into mass is given 0.02 into v square is equal to 9. So when you solve this, v square is equal to 9 upon 0.01, which is nothing but 900. 9 upon 0.01 is what? 900. So that will give you v is equal to square root of 900, right? And that should give you 30 meter per second. So that is the 30 meter per second. Yeah, that is the speed of the ball, the velocity of the ball with which it hits the ground. Very simple, very simple. V square was 900, so v is square root of 900, that's 30 meter per second. Now see, the rebounding has happened. The ball again goes up. After hitting the ground, the ball goes up to a height of 40 meters. It's told in the question. You read the question. It rebounds from the ground to a height of 40 meters. Now understand what is happening. So after it has hit the ground with 9 joule of kinetic energy, some part of kinetic energy will now convert to other forms of energy. Heat energy, sound energy, whatever. Okay. Now let us say x joules of kinetic energy got lost. That is actually what we have to calculate, the loss in kinetic energy. Let's say x joules of kinetic energy got lost. So now this body is having 9 minus x joules of kinetic energy, the remaining kinetic energy, because x joules have got lost in some has got converted to some another form of energies. So 9 minus x joules is still the kinetic energy left with the ball after it has hit the ground. Now this 9 minus x joules will cause the ball to go up to a height of 40 meters, and at 40 meters, that 9 minus x joules, which was the kinetic energy, that 9 minus x joules will convert to potential energy when it is at 40 meters height. So let us calculate the potential energy of the ball. Let us calculate the potential energy of the ball when it is at 40 meter height. Let us calculate the potential energy of the ball when it is at 40 meter height. Why are we doing so? First, let us calculate the potential energy of the ball at 40 meter height. So after rebounding, it is going up to a height of 40 meters. So we'll use the same formula for potential energy, mgh. Mass is 0.02 kg, g is 10, h is 40 meters. Now if you calculate this, this is 8 joules. 8 joules. Now children, this is the potential energy of the ball at 40-meter height. At 40-meter height, so 8 joules. From where did this 8 joule come from? This 8 joule is nothing but the leftover kinetic energy in the ball, which got converted to potential energy when it rebounded and reached the height of 40 meters. Are you getting the point? The leftover kinetic energy, that means 9 minus x, the leftover kinetic energy. That 9 minus x, the leftover kinetic energy, is actually the 8 joules. Because that leftover kinetic energy, which did not convert to sound energy, heat energies and other forms of energy, the remaining kinetic energy, that caused the ball to rebound, and that caused the ball to go up to a height of 40 meter. So entire kinetic energy present after rebounding happened, after it has stricken the ground and the rebounding has happened. So remaining kinetic energy will convert to the potential energy at the height 40 meters. So this 8 joule is nothing but the kinetic energy of the ball after striking the ground. After striking the ground. When I am writing after striking the ground, means it has stricken the ground and some forms of energy have got lost. Some form of kinetic energy, some amount of kinetic energy got converted to heat and sound energy. So the remaining energy is 8 joules. That means earlier the kinetic energy of the ball was 9 joule, with which it has come and hit the ground. But after hitting the ground, when the loss has happened, the remaining kinetic energy is 8 joule. So how much of loss has happened? What is the loss of kinetic energy? 9 joule minus 8 joule, that is 1 joule. Therefore, this is what we have to calculate. Loss of kinetic energy, isn't it? You have to find the loss in kinetic energy on striking the ground. On striking the ground is equal to 9 minus 8 joule, that is 1 joule. Isn't it? The question is so simple. So we have solved this question. It was really interesting question. Such types of concept-oriented competency questions are now frequently asked in board exams, and this is the reason why I am doing the competency series. Children, this competency series is really helpful for you, and if you watch it in a proper sequence from question 1, question 2, question 3, question 4, and I have arranged all of the questions in a proper sequence in a playlist whose link is given in the description box of this video. So make sure to click on that link and go to that playlist and watch each and every video in a proper sequence. Also make sure to subscribe to the channel and press on the bell icon and turn on all notifications so that you don't miss any of the videos that I would post. Take care and have a nice day. Keep learning.